Have you ever just stopped and wondered how a machine can write a poem that actually moves you? Or solve a tricky math problem? Or even find a bug in computer code? Well, today we are pulling back the curtain on large language models, or LLMs, to really understand the magic behind the machine.
I mean, it really does feel like magic, doesn't it? You type something in, and what comes back is this perfectly coherent, sometimes incredibly creative response. This whole ability for a machine to understand and generate human-like text is, without a doubt, one of the biggest leaps in technology we've seen. So, how on earth does it actually work?
I mean, think about it. We're talking about the same model that can, in one moment, write a beautiful story about a secret garden, and in the next, give you a solid recipe for homemade ice cream. Then it can turn around and tackle a complex math problem, and then write and fix a program in Python. It's this insane versatility that we're going to unpack right now. To really get the magic, you have to start at the very, very beginning. Because the entire foundation of an LLM is built on an idea that's, believe it or not, incredibly simple, but also incredibly powerful. Okay, it all boils down to this: just predicting the next word. Seriously, that is the fundamental task. At its core, an LLM has been trained on just a mind-boggling amount of text from the internet, from books, from articles, trillions of words. And its only job, repeated billions and billions of times, is to guess what comes next. The cat sat on the mat, or maybe floor, chair. By doing this over and over on a scale that's almost impossible to imagine, it doesn't just memorize sentences. It starts to learn the patterns, the grammar, the context. It learns the concepts that actually make up our world. So what turns this simple word-guessing game into something so powerful? Well, it's a concept called scaling laws. This was a huge discovery. Researchers found out that if you just massively crank up three things: the size of the model itself, the sheer amount of data you feed it, and the raw computing power you use, the model's abilities don't just get a little bit better, they get predictably and exponentially better. This is where things get really weird and cool. At a certain massive scale, these models start showing off what we call emergent properties. These are abilities they were never, ever explicitly trained for, like reasoning or problem solving, and that is why these models are so gigantic. And this is what you get. After all that training, what you have is called a pre-trained model. The best way to think about it is like a brilliant intern who has read literally everything. Every book, every article, the entire internet. They have this immense, unbelievable amount of knowledge just packed in there. But, and this is a big but, they don't yet know how to follow your specific instructions. They're like a vast library, but not yet a helpful assistant. So the big question is, how do you take this raw, super knowledgeable model and turn it into an assistant that's genuinely helpful and safe? Well, that's the next crucial step in this whole process. This is called the alignment process, and it's this really fascinating three-step dance. Okay, so first, humans create this high-quality set of examples, prompts and perfect answers, to basically show the model how to behave. Then, they train a whole separate AI called a reward model to basically act as a judge. It learns to look at two different answers and decide which one is better. And finally, that AI judge guides the main LLM through millions of examples, rewarding it for generating responses that are helpful, harmless, and just generally aligned with what we want. And let me tell you, the difference is just night and day. Before this fine-tuning, if you ask the raw model to summarize an article, it might just keep writing the article, because that's all it knows how to do: predict the next word. But after fine-tuning, it understands the instruction. It gets that you want a summary, and it gives you one. This right here is the leap from just having raw knowledge to having actual, practical usefulness. Okay, so now we have this powerful, aligned model ready to go. The final piece of the puzzle is us. It's the user. Because how we ask questions, how we prompt the model, can totally change the outcome. Let's just take this simple little math problem. It seems straightforward for us, right? But it actually requires tracking several steps, which can be a real challenge for an AI that's, at its heart, still just a next word predictor. And, yep, when you just ask it directly, the model makes a mistake. It gets the answer wrong. Now, this isn't because it's bad at math. It's because our simple prompt didn't really give it the structure it needed to think through the problem step by step. This is where a really clever technique called chain of thought prompting comes into play. Instead of just asking for the final answer, you show it an example that breaks the problem down into logical steps.
By showing the model how to reason through it, you're basically guiding it to the correct answer. You're teaching it to show its work.
And what's absolutely amazing is that researchers found you don't even need to give it a full, detailed example. Just adding this one little magical phrase, "let's think step by step," at the end of your prompt is often enough to trigger the model's own internal reasoning process. It's incredible. It dramatically improves its performance on all kinds of complex problems. It's like a simple little key that unlocks a much, much deeper capability. So think about this journey. We've gone from a simple word predictor to a brilliant intern to a helpful assistant, and now to a reasoning partner. And it all leads to this final, really big question. If the key to unlocking an AI's true potential isn't just about making it bigger, but about teaching it how to reason, then what are the limits to the problems we might be able to solve together?